Welcome to Hyperledger on Azure Expert Talk. We're going to cover everything from the basics of blockchain to the benefits of Hyperledger on Azure. I'll be answering questions in the chat at the end. So let's get started. I'm Brian Nielsen, and I will be your instructor for this expert talk. I'm a senior cloud training architect with Opsagility, and I've been working with Microsoft Azure from its earliest days as both an IT pro and developer. Over my career, I've worked with organizations from all sizes from Fortune 50 to Fortune 1000. You can contact me via email or LinkedIn. For this session, I want to give everyone an introduction to blockchain and what problems it is trying to solve. Then I will discuss blockchain and cryptocurrency. I promise by the end, you will realize your workflows and data will not have to be involved in the volatile Bitcoin price. Then I'm going to cover different generations of distributed ledger technology. It's important to understand that this is not a brand new technology and it has evolved over time. Next, I'm going to introduce some core features of Hyperledger and compare it against another blockchain technology, Ethereum. Finally, I'm going to discuss the benefits of hosting Hyperledger on Azure. So let's get started. Blockchain, it enables businesses for supply chain, healthcare, and government, to name a few. Blockchain at its core is equivalent to a digital ledger. If you think of an old-style ledger for tracking financials, you would normally not erase a line if there was a mistake made. The impact to the rest of the lines would be massive. You made an additional line entry noting the discrepancy. Modern blockchain provides trust and transparency, immutability, where you cannot delete data, smart contracts, consensus, and decentralization. If you consider how most applications are generally written, there's normally a database in the background. While normally accepted as a good solution, what occurs when someone decides to alter the actual database? It is usually very difficult to detect the appropriate versus inappropriate data changes in a database. So consider a scenario where you had a group of people working on a paper to be published. All of the documents are stored in a database, but one person in the group notices the paper may win a Nobel Prize and doesn't want to share the award with the rest of the group. There is nothing preventing the others in the group from being removed. The nefarious actor could go into a single place and make the change, and it would be instantly changed in the database and reflect in the application. Even though a lot of money is spent on security, firewalls, etc., it is all residing in one single location. Let's look at what happens if you buy a book on eBay. Once you find a book, you would probably pay with PayPal, which points to your credit card at your bank. Everything works great, but everyone is charging a fee. eBay, of course, has listing fees and charges a percent for sales. PayPal also charges a fee. Then your credit card transaction has fees on top of that. If you compare this to an in-person transaction, using cash, there are no fees attached, but now you've lost the traceability of that transaction. So how do you solve problems like making data completely immutable while being massively scalable? Provide traceability to every shipment or transaction. Reduce the number of transaction fees and intermediaries between a transaction. This is the core of what blockchain was designed to solve. If we consider this blue block to be a block in a blockchain, it can contain any kind of data. It also contains information or metadata. And sometime later, another block is added, and it also contains information. Additionally, this second red block explicitly states I am attaching myself to the blue box. Then another block is added with even more information. It will also state that it is linked to the red box. This is now a sequential order of blocks. Block 1, block 2, and block 3. Each of these boxes says I'm block 3 and I'm linked to block 2. Block 2 says I'm linked to block 1. This creates a chain of blocks, a blockchain. It is important to understand that each block also contains information, so it is basically a database. Even when searching the Azure site for services, blockchain is categorized under the database section. One of the core differences of a normal database versus blockchain is that blockchain is decentralized. A database architecture loosely would resemble something like this, where the client applications connect to a central database. But if something or someone corrupts the database, the data is just wrong. But the decentralized nature of blockchain means that every node on the network participating has a copy of that blockchain. These are exact replicates. So what is a node? Anyone that has a computer can be part of the network. Let's scale this out just a little differently. So let's pretend the node count is in the hundreds, thousands, or tens of thousands, all of the duplications of the blockchain. But all of a sudden, one of the nodes becomes disconnected. What happens then? There is zero problem because all of the other nodes still have the data. When the node comes back online, it easily duplicates the existing blockchain data and syncs up with the remaining nodes. Let's revisit one of our previous scenarios where someone's name was going to be removed from an article. Assuming that data resided in the red block, and the user deleted the data on one environment. So now the blue is connected to the yellow. What happens now? Obviously, number two is missing, and block number 3 is connected to block number 1. The entire blockchain will notice that this one node is not valid and corrupted. At this point, it will be rejected from the network. This is how decentralized blockchain works for data integrity. This is also known as consensus. There are tons of articles and mathematical proofs regarding defining consensus. Let's take a look at a use case. How often have you heard of a recall on meat, turkey, chicken, or spinach? This is an article about Cargill, one of the largest meat solution companies in the US. One of the recalls from Springdale, Arkansas involved 36 million pounds of ground turkey. The turkey had been contaminated with salmonella. It had killed one person and sickened 76. The amount of turkey recalled was enough to fill 36 Boeing 747 commercial airplanes. Cargill has now become a leader in the search for better traceability for the farmers that provide their turkeys. If you have noticed in the last few years, there's a tracking code on the outside of frozen turkey breasts. The scale for this is massive. Just over the holiday season, this equates to over 6 billion pounds of turkey meat. This is a simplified flow of how the physical flow is coordinated with the digital flow and finally stored in the blockchain. If you notice on the bottom row how the blocks start combining, this is exactly like I was mentioning before. But starting at the top, you might have a grain provider. Next to that is the producer. In the past, if there was a delay because of an accident, the producer might not be notified until it is too late to place a different order. With this kind of flow, the producer is directly aware of the grain location and timetable. Next is the producer to processing. This can track timetable and additionally track the number of animals transferred to the processing plant. The processing plant can add additional data, such as workers that were assigned for that particular lot, the temperature outside, the temperatures at every stage of the processing process. During the distribution process, it is temperature sensitive, and you could utilize Internet of Things to constantly update the temperature to ensure that it never drops below a certain threshold. The retailer has access to all the previous data and could reject it based off meeting key performance indicators to protect the consumer. Finally, the consumer has more information available and makes it much easier to track if there is a recall. And I just see we have a question, how to differentiate between valid delete versus accidentally corrupt delete. I will go into that a little bit more at the end, but I'll go ahead and finish the presentation, but I appreciate the question. So let's go through blockchain and cryptocurrency. Whenever I bring up blockchain, there's a lot of conversations with, and normally the first thing people will say is, what about Bitcoin? Is it currency? Can you trust it? Is it the same as money? How do you spend it? How do I attach my data to Bitcoin? Can they steal my data? So I hope to dispel any rumors or misconceptions about blockchain and cryptocurrency and understand that all blockchains fall under digital ledger transactions or DLT. Starting at our basic blockchain again, the underlying question is, how is a block created? Why would you store that blockchain data on your machine? Doesn't that waste space? Doesn't that waste energy? When the first generation of blockchain that utilized Bitcoin was released, The concept worked great until two blocks were created at the same time. In order to prevent this collision, Bitcoin introduced something to slow it down. This is called proof of work. It is basically a very complex math problem, and it's provided for the computers to solve. The incentive to solve the math problem is actually the cryptocurrency, or in this case, the Bitcoin. So the incentive to spend compute time and electricity is the reward of the Bitcoin for generating the block. This is called mining coins, and that is how blocks are created. Digital ledger technology. This all started with recording records in stone, then moved into clay tablets, the paper then ledger books. Ledgers have shifted to a global network of computers, which are cryptographically secure, fast, and decentralized. A distributed ledger is a ledger of any transactions or contracts supported by a decentralized network. When referring to a blockchain, all blockchains at their core are distributed ledger technologies, or DLT. The first generation was cryptocurrency. The thought with Bitcoin was to create a non-fiat currency not controlled by the government, and no one person could control the generation of the currency. It was an amazing technology that continues to evolve and has great blockchain behind it, so it remembers all the transactions behind it in this distributed ledger. The next generation looked at storing other information in the ledger. You look at something like a land deal. In all actuality, if you wanted to make a photocopy of the deed and sell it to multiple people, you potentially could. But with the ledger, you would be able to drill down and verify that the deed was only allocated to one individual. The next generation introduced smart contracts. So now you could do distributed applications, elections, non-repudiated agreements, or sales contracts. The current generation looked at the previous three and realized they had money, traceability, and sales transactions. So the next place to add would be markets, some place where buyers and sellers could be matched up. This could be games, stock markets, auctions. When you're looking at creating an enterprise blockchain, there are 5 pillars that you need to consider. At a minimum, these are the 5 core things that you should have. The first is going to be private. The main difference with enterprise blockchain is the ability to exclude the public. There is a defined permission architecture that goes beyond access to everything. If you consider Bitcoin in comparison, you can visit a site like blockchain.com and view all the latest transactions. If you dig in the details of a transaction, you can even see the amount transacted. Obviously, this is not something you want for an enterprise application. One of the benefits of Hyperledger is you can restrict the viewing based on the peer or order. So basically, clients can only see their own pricing and transactions. Next is for it to be decentralized. This is fundamental. This allows equal control over the shared database for all allowed participants. It allows distribution of full copies of the ledger to a large number of nodes. Immutability and data integrity are one of the best features of blockchain. The records are guaranteed to be cryptographically secure with zero possibility of bad actors having the ability to threaten data integrity. As with most technologies nowadays, scalability is crucial. The ability to handle millions of transactions without compromising the network synchronization, security, or accessibility or data integrity. Finally, is security. This means that data management and enforcement of complex permission settings for participants and third parties. There are many DLT blockchains available, but I'm going to compare 2 of the most high-profile ones in the enterprise space, Hyperledger and Ethereum. When you're looking at the core features between Hyperledger and Ethereum, you'll notice that Hyperledger is very focused on the B2B business. Ethereum can do B2B, but it's more focused on B2B and building dApp applications. For security, Hyperledger is confidential. Ethereum, like the Bitcoin that I demonstrated earlier, it is transparent and it is visible. With a peer network, Hyperledger is going to be extremely private and permissioned. With Ethereum, it is public and private, but it is permissionless. With regards to the consensus algorithm, the big difference between Hyperledger and Ethereum is Ethereum is still going to require that proof of work or data mining. There's actually a consensus algorithm inside of Hyperledger which eliminates the need for mining. Programming languages you're open to a lot more with Hyperledger, and Visual Studio is actually offering even more. Ethereum only has Solidity currently. Since there is no mining involved in Hyperledger, there is no cryptocurrency either. With Ethereum, there is the Ether token. For transactions, you're over 2,000 transactions per second with Hyperledger. With other consensus algorithms, you can get into the hundreds of thousands of transactions per second. Remember, Hyperledger is pluggable. Ethereum, you're about 20 transactions per second. As comparison, if you had a transaction where company A is sending company B a product, the application is built, it will do a query to find company B on the network. The membership service will validate these permissions, and the Hyperledger will connect the two parties directly. Both companies receive a verification of the transaction. What is unique about this transaction compared to an Ethereum transaction is that company B can have a different negotiated price than company C, but the agreement and the pricing are completely confidential. That's a true benefit of going with Hyperledger versus Ethereum. Hyperledger is completely private, and it's a permission network where Ethereum can either be public or private, but it does not have the permissions capability. This means that in Ethereum, anybody can participate in the network at any time. But Hyperledger has a predefined community of participants, and access to the network is restricted only to them. One requires permissions to join the network, and this mode of participation has a profound impact on how consensus is reached. Let's take a look at the benefits of Hyperledger on Azure. The biggest benefit is with minimal knowledge of Azure and Hyperledger, you can now set up a blockchain consortium on Azure using the solution template by providing a few basic input parameters. One of the major hurdles of setting up blockchain is the infrastructure, certificates, network, and Kubernetes. Some of the top features of Hyperledger Fabric on Azure Kubernetes, it supports the latest version of Hyperledger Fabric. It also supports the deployment of the order organization and peer nodes. The Fabric Certificate Authority can use self-signed certificates, or you can upload a certificate from your root and use that as a certificate authority. It supports running level DB or CouchDB. The ordering service runs highly available raft-based consensus algorithm. You can also choose different consensus algorithms. It supports ways to configure in terms of size and nodes in Azure Kubernetes. It does have public IPs exposed, so you can attach to different networks and different organizations. It enables you to jumpstart building your network sample to scripts to help post-deployment steps, such as creating workflows or consortiums and channels and adding peers to the channel. There's also a GitHub site that has a Node.js application sample to support running a few native Hyperledger Fabric APIs, such as new user identity generation and running custom chain code. Azure makes it easier with the template available on their marketplace. This allows you to focus on building applications and connecting other customers rather than worry about the underlying infrastructure. This template helps the customers to deploy the Hyperledger Fabric network on Azure Kubernetes service clusters in a modular manner that meets the much required customization with regard to the choice of Azure Virtual Machine series, number of nodes, and fault tolerance. Azure Kubernetes Service provides enterprise-grade security and governance, making the deployment and management of containerized application easy. Customers anticipate leveraging the native Kubernetes tools for the management plane operations of infrastructure and call Hyperledger Fabric APIs or the Hyperledger Fabric client software. HLF has two main components. The first is the ordering service, which is specific to the founder organization who created the instance, as you can see with the red highlights. For each subsequent organization you can add, there will be a peer node, which is highlighted in green. Let's walk through a couple of the screens to set up a Hyperledger Fabric on Azure. The first screen purely defines the description, resource group, region, and resource prefix. The resource prefix will be added to all resources upon creation. The fabric settings require the information similar to the last graphic, and it helps you define the network components you're creating, either the ordering service or peer node. One of the ways that Hyperledger Fabric on Azure maintains security is the certificate authority. Here you can see that you can create a Fabric self-signed certificate or upload a root certificate for Fabric CA to utilize. Next is the Azure Kubernetes cluster settings, and you can set up the name on the Kubernetes version and DNS prefix. There are some default node sizes, but you can adjust those as you see necessary. Then the initial node count. This number can be increased later. As with most services in Azure, you can scale up or down based on the need to reduce cost or scale up during busier times. And as a quick summary, we went through the basics of blockchain, went through the basics of blockchain and cryptocurrency, just kind of dispel any rumors that the price of Bitcoin was going to affect any of your data, looked at distributed ledger technology, and we also covered the 5 pillars of enterprise blockchain, compared Hyperledger and Ethereum, and looked at the benefits of using Hyperledger on Azure. I sincerely thank you for taking the time to listen to this presentation, and I hope this helps in your decision to investigate putting your next project in Hyperledger on Azure. And I do see a question. It's how to differentiate between valid delete versus accidentally corrupt delete. So basically with this, you're looking at, based on that consensus algorithm, is if you're looking for basically a bad actor that's going to come in and manually update something. The ability to manually update something versus the application pushing the information to the peer node, that's going to be the difference. So you're looking for somebody physically coming in and corrupting data. That's actually almost impossible to do with blockchain. Does that answer your question? And I'm also open for any other questions. Sure. And also with the valid delete versus accidentally corrupt delete, since it is a ledger technology, you do have traceability. It's like going through logs, and you have full traceability to every transaction that did occur. So if you needed to figure out what happened, you could get that information. And just seeing if anybody else had a question. So the next question is, what kind of project is this used for primarily? So the underlying question is, I guess the first question is, do you need to store data? Okay, if you need to store data, there's a potential to use blockchain. Do you need to require permissions for this data where you basically have discrete roles? Do you need to be able to integrate with multiple people? And you need to have full traceability with completely immutable data. So like I was demonstrating with the cargo simulation. Another one is healthcare. So consider the healthcare where you're going to provide insurance information or you want to provide healthcare information and you want full transparency and you want to be able to track down every single touch point and you want to be able to see who viewed a particular file or who viewed a certain x-ray. And you want everything from the first time that somebody enters a hospital to the last time that they exit the hospital. And you want to have full traceability to every encounter that particular individual has. This can also work with the music and film industry. So if you want traceability to who's opening up certain files and prevent people from sharing files online. So you'd have traceability. So, oh, this person downloaded this MP3 file on their local machine. Why are these people, should they have access to that? So if you're in the middle of developing a film and you'd be able to access all the frames, all the audio, all the video, to be able to trace who has access to it. And then if there's something was accidentally released to the public or purposely released to the public, you'd have traceability to who had access to that particular piece of data. That makes sense for your question, what kind of projects? And any other question? Next question is, can we take an old database and convert that to blockchain? That would be no. So the blockchain is not going to be anything similar to an old RDBMS database. The application is going to be entirely different also. And it would work very much the same as connecting to a web service. So a super simplified way of thinking of it is you're going to completely separate the data layer from the web application. The data layer is now going to be obfuscated into a service. The service is going to take care of all the permissions, going to take care of which peer node it's going to, and which order it's going to. So it's a completely different mindset than just taking an old database and converting that to blockchain. You could potentially reuse the UI, but you'd have to write a separate data layer to connect to the blockchain network. That answer your question? So the question is, could we read data from an old database into a blockchain? Or can we lock the database to read only and slowly build that data into a blockchain? You could absolutely script something like that out. So there's nothing that would prevent you from doing a scenario like that. But it would be something that you would either script or programmed out, that you'd go through each record individually and then add that record into the blockchain. So from a comparisons perspective, it would be, if you're looking at a regular database and you were looking at a CQRS implementation, it would give you a full ledger log. So you'd want to be able to write your information out. So it would work more like a ledger and rather than a database. Yes, that's exactly right. So a layer where users are tracked accessing old data in the Hyperledger. That's correct. Because the objective of this is to provide touch points to every single access to the data. And you don't have to provide everything, but the objective is to provide as much as possible. And to see if we have any other questions. Well, if we don't have any other questions, I'm probably going to end this at 30 minutes past the hour and give everybody back a half hour up. I appreciate the compliment, and I hope it was a good overview for you. I was trying not to go extremely deep into Hyperledger, but make sure that everybody could actually understand what blockchain was. A lot of people do not understand blockchain is more like a database than anything like that. The vast majority of the world views blockchain as just Bitcoin. All right. Well, I appreciate everybody's time. I'm going to go ahead and conclude this. I'm glad it makes sense to you. Take care, and I hope everyone has a very, very good day.